And we are live, and it even works, I think. So, of course, the nice people in the chat will now say things such as, I can't hear a thing, even when they hear everything. And then I'll be confused, but I'm actually pretty sure that we can be heard. And so, well, good evening, boys and girls. Welcome to the global uprising of the Uncool. And we have an amazing guest here that I'm sure is close to being as intoxicated as I am. Please do something like clapping, but online for Simon Mitchell.
Thank you.
I will now imagine, a crowd going totally wild.
Deafening. It's deafening.
Totally freaking out. Yeah. So this is all cheering that social distancing allows. Yeah, I'm super happy here to have Simon here, which is a person that I met at Resistance, I think, right? Or did we meet anywhere before?
My memory is meeting at Resistance. My memory is you, and this could be totally wrong because you know how Resistance memories are. You were very tired, and I had caffeine pills, and I was your savior that day. And you were very grateful to get caffeine pills, and I think we traded them for the Ahoy Browse like sherbet candy thing you had. I think we swapped. We basically dealt drugs, but it was caffeine and sugar.
I traded sugar for caffeine. That's actually a good trade, right?
I think you came out okay. I was very happy too because I couldn't get it in the UK and you needed it badly. I think it was the last day that we really you were struggling.
Yeah, I must have been struggling. I would think that it must have been. I don't know. Was it the first one or? It must have been one of the earlier ones.
Because 2012, the first one, I think.
Because later on, I have actually more memories of people talking about that there are no real Simon Mitchells around. And so because of that, we were just carrying like pictures of you and even made announcements on stage. And then people thought you were dead.
Yeah, so that whole thing, I mean, that's out of hand. That's something that I may not even be able to explain very well because I wasn't involved in all of it. But long story short, I was not there 1 year, and to most people that's fine or they're glad. But to Mark Haig, it was the end of the world, and so a laminated picture of my face came out and was my surrogate, and he tried to get as many pictures of me and various people to
came also at us at a couple of other situations. Like I think Alexis mentioned that too, because he was walking somewhere in LA, obviously. Then obviously was like, is this real? Was I like holding this thing in my hand and
Face looks familiar.
that must have really creeped him out because I was in LA. I think I saw them at the Viper Room or something, and so I kind of, I didn't introduce myself because I didn't know he'd know who I was, but I saw it in his eyes that he was like, wait, where have I seen this guy before? It can't be where I think it is because he's in LA and I thought he was in Sheffield. So yeah, I did see him roughly.
Yeah, he in fact had to hold like a picture for you, for people to take pictures with it, and some of them are still around. I mean, yeah, and Mark was wearing this bra, and then all of these things happened. Yes, so it's pretty weird, you know, when you know a person where you can almost tell more stories about him on the event where he wasn't there.
Yeah, it extended to Facebook with like various Facebook groups about me, various fake accounts about me, because Mark Haig wanted to make me feel involved. So he would tag me in everything, even if I wasn't involved, and it would end up with different Simon Mitchells. I made friends with other Simon Mitchells through Facebook spam. There's a Simon Mitchell company that does something. There's a scuba diver called Simon Mitchell. It got very out of hand, but it was all because I was missed, so I don't mind.
Yeah, I mean, when Mark misses you, you know, it's you never quite know whether this is, I don't know. Sometimes that's difficult.
I was worrying how far it was going to go. I wondered if I would like lose jobs because there was like pictures of me in compromising positions that I wasn't involved in. But no, so far it's not got in the way of my work, so I don't mind.
Yeah, at least nothing was streamlined.
Yeah, he did take a door off my house once, but that's another story.
Yeah. So that's totally great, and well, this is how I met you, which is which is quite fantastic in itself, and well, one of the reasons why I invited you to come over is actually you know, while we talked about that before we actually came online, I talked a little bit about my job, which is I think like one of those positions that some social philosophers would call bullshit jobs that are quite okay paid, you know, and you sit at tables and then you make decisions on stuff and you tell people that they are wrong and things like that. But in the end, it helps like a multinational corporation to print weird pictures on dead wood and then send this to people where you are not quite sure whether they actually want this dead wood. And and there's a lot of money involved in this dead wood, and so I help them with that. And on the other hand, I mean, sometimes I'm also on stages or people for some reason find it to be fun to watch me while I'm drinking in my living room because I can't go out. But among those people that watch this bullshit, I find people that are actually doing way more interesting things than I do, and among them is obviously you, because you are not just a real Simon Mitchell. Oh, the sound cut out. I don't know when the sound cut out, but I think I will just continue now. So yeah, well, this is a real Simon Mitchell, but it's also Simon the Scientist, and actually, perhaps you like to say some things about what you actually do while I'm doing a bullshit job.
Okay, firstly, don't play down what you do, because musician, DJ, whatever bullshit corporate job, all juggling that and running isolation parties, yeah, you're not as uncool as you think. So yeah, so I'm a scientist, but it feels weird to say that, because what does a scientist even do? I basically
Science,
stayed
obviously.
in school until I didn't really know what I wanted to be when I grew up, and then I had like summer jobs where I didn't like them, and then I had, you know, I worked in a bank or worked in a call center, and you know, did normal jobs, and kept thinking, oh, the real world's a bit shitty. I'm going to go back to school and keep learning, and kept learning, and that means you end up getting a PhD, and you end up getting a postdoc after your PhD, and then really you're a scientist for a job. And then now I have my own lab running my own science.
Is it really in this way that you actually most of the time end up in some sort of an academia position because you just simply decide not to stop?
Kind of, yeah. I didn't. At some point, we don't earn much, right, compared to what you might earn if you were to go and do something corporate. So you have to have some commitment to wanting to do it for the right reasons. But if you just keep doing it and staying in school. And the logical job after a PhD, if you still want to do science, is staying in academia. You can go work for a business and make money, or you can stay in science and gradually progress until you become a professor. So that's what I did. And just changing disciplines all the time, because I find the enjoyment from doing a bit of everything, and never really settled in one place. But that eventually led me to this weird thing that I do now that sits somewhere between a bunch of different science topics.
Yeah, because I saw, I mean, you wrote a paper that I find that to be quite impressive. You know, when I post something on social media, I get like, I don't know, some retweets or something like that, or someone likes it or whatever. But you wrote a paper in 2016 that, according to Google Scholar, has like, I don't know, 250 citations, which is quite a bit, I guess. So what happened there?
That paper's wild. It's not my favorite paper. It's not my best paper. It's not in the best journal, but it really took off. And I think what it is, it's a review of a very specific thing. And I was at the time working in a lab that was one of the leading labs on this very specific protein. So we wrote this review and it got cited so much. I think not because it was particularly groundbreaking, but because we made something difficult seem fairly easy. You know, we explained it with pictures, with diagrams, in a logical way. And so many people who are coming to the field and trying to understand this very specific protein that's involved in your immune system would read that paper as a first step. And so almost any paper in the field about this protein, you'll see like Mitchell et al. At this very start, just as a sort of introductory. One of the first sentences always mentions that paper, because it's a good overview of what we knew at the time in 2016 or whenever it came out. So it's not really the most groundbreaking of my work. It's not my most exciting, but it's the one that people find easy as an introduction. That's why it got so many citations, I think.
I guess, yeah, and it's mainly about inflammation, right? Or about some sort of a communication factor or something like that triggers inflammation.
Right. It's about this protein, my favorite protein. Once you become enough of a science nerd, you have a favorite protein. Mine is NF kappa B. It's involved in inflammation. So when your cells sense danger, and that danger might be a cut, it might be bacteria, it might be a virus, it responds to all sorts of different danger signals. This protein is activated, it shoots to the middle of the cell, and then it turns on a bunch of genes that do a bunch of different things. So it's really important for our immune systems, it's really important for inflammation, and it's involved in it's regulated in a really interesting way within the cell. So the paper's about that and about how that happens.
And so what this gives is it helps us to understand inflammation generally better. Yes, I mean,
right, and helps us understand how inflammation is triggered and how it resolves. Because when you get a cut on the knee, you want some inflammation. That inflammation is your body saying, "Oh shit, something's gone wrong here." There's a dangerous signal. That goes out to the rest of the body. The blood vessels dilate, so you get more blood in the area, which is why it feels hot and red. And it's your body saying, we might have an infection, we need to treat it. And usually that goes away and your knee gets better. But sometimes you get inflammation that lasts a long time, this chronic inflammation, and trying to understand what goes wrong then is really important. And to understand what goes wrong, you need to understand what goes right. So that paper was really about trying to understand what goes right and wrong in various conditions with inflammation.
I mean, in typical internet bro science, right? You continuously find people that are telling you, hey, you know, all of your problems are because of inflammation somehow. Because of that, you should eat more avocado or whatever, because this is an anti-inflammatory and that's somehow great. But is this great now, or what does it actually do? Does it do anything?
Yeah. So anti-inflammatories tend to be good for you because they're in lots of good foods, right? I'm not a nutritionist, so I'm not going to talk as too much of an expert on the diet, but And chronic inflammation is bad for you. We're exposed to lots of things that give us inflammation all the time, even like the sun and foods we eat. Chronic inflammation is a problem, and foods that people think of as anti-inflammatories and avocados and all this stuff are good for you. But if we had no inflammation, our immune systems just wouldn't respond to a cut on the knee. We'd get sepsis and we'd die. So there has to be some inflammation. Inflammation is not bad. Inflammation is an important part of our immune processes, but it's the sort of too much inflammation that we try and fight with good foods.
I mean, of course, when you're reading, like, I don't know, articles on the internet, they're, of course, always set up in a way that you can, condense the context to some sort of clickbaity headline, which is something like, wine is actually good for you, even when it's, even when it's bad for you. And then people are trying to put things in some sort of good and bad boxes, and say preposterous things that actually no one ever said that way, but everybody feels like informed about that. And the end of the story is usually that someone in Berlin is trying to burn down a 5G mast. So is this something that you generally encounter a lot?
Yeah, all the time. And it's easy to blame these people burning down 5G masts as stupid people that there's nothing we can do about. But there's some weird incentives that go into that happening, right? Like the people who write the articles make more money if more people read it. So the headline that might be slightly true becomes amplified to get more people to click on it, so they get more ads. But then the scientists have some blame as well. As a scientist, our wet dream is to have a press release in a big, in like a newspaper or a magazine that people know. And when that happens, they come to you, the reporter comes to you and wants to report on your science because maybe your avocado is now causing cancer and they want to talk to you about it. And they're looking for like the most amplified version of that. And scientists let it happen. So it's on the scientist as well to make sure that the science, the reports that go out about their science are accurate. And we screw that up a lot because we want the headlines too. We want the attention towards our work. It helps us get the next promotion. So it's not just people being stupid. It is scientists dropping the ball and journalists not, motivated by money.
But I just heard we have questions, which is great because that didn't even make sense that this is a live stream, right? That's so cool.
So Nina wants to know, someone recently told me that the body needs to be allowed to inflame a bit, and so I shouldn't take ibuprofen. Is that person talking bull?
Perhaps people didn't quite hear that. So the general question is, people need to allow their bodies to inflammate a little bit. So because of that, you shouldn't rather eat ibuprofen or the like, I guess.
Yeah, I think I mentioned it a bit. Inflammation is an important process that we have to go through. Chronic inflammation is not good. Ibuprofen you should take if you need to, and if your doctor is okay with it, and if you have been taking it, keep taking it. Some ibuprofen is not going to totally stop all your inflammation, so I wouldn't worry too much about it. There's no big new breakthrough that says ibuprofen is killing you. Just keep doing what you're doing.
I mean, from a rather personal perspective, from my side, I'd say that ibuprofen is one of the substances that I rather didn't feel like they could become a habit for me. But
anything can.
For other reasons. Yeah. So now you ended up knowing all sorts of stuff about inflammation. Why actually? I mean, that's great. I mean, I'm sure that there must be people that know all about inflammation, but I guess you know that for a reason, right?
Right. It was. It's been a weird trajectory that's taken me to inflammation, and then from inflammation to the immune system in general, and now more cancer research. But the reason I started looking at the immune system initially was just this protein that I wrote that paper about, that rushes into the middle of the cell, has some really cool properties that you can simulate on a computer. So I make these simulations of this protein, and it does some really cool stuff. So that's why I started looking at inflammation, more because it was cool from a computer science side, because I wanted to simulate it on the computer. Then it led me to some insight about biology, about inflammation, and now about cancer.
So this is why it says computational systems biology, yes? So are you one of those people that are like putting data into folding at home or something like that, or?
Yeah, that's not a million miles away. It's really interesting. So there's computational biology is that's what computational biology is. It's big data, like folding at home, like all this DNA sequencing you hear about. That's computational biology. The systems bit, so I do computational systems biology. The systems bit means that I'm doing these simulations of our cells. The same way some people simulate the weather or simulate in a game how Mario might jump and he obeys some rules of gravity, and the speeds are represented by equations. I do that for this protein and the immune system and the way it responds to damage. So I'm simulating, rather than simulating the weather or simulating Mario, I'm simulating cells responding to an infection or responding to damage with a computer.
And you started out with simulations even in your PhD phase, right? As far as I understood, you simulated something about what we do with iron, right?
Right. So I did so my undergraduate degree at university was computer science and maths. I didn't like biology in school. It was labeling parts of plants and I hated it. And then I did my computer science and maths and wanted to do a PhD because I had a summer job in a bank and realized it was soul destroying. So then was looking for what PhD to do. And this guy that I found called Pedro Mendez had got basically a diagram of everything happening in the cell that involves iron. So how does the iron we eat, and some people take iron tablets and some people are anemic. He had really mapped out everything that happens with iron. And so that, to me, what I could now do is simulate it, because I can just put numbers on each of those rates, each of those lines that he drew, I can turn into a simulation quite easily because he has it all mapped out. So that seemed like an easy PhD in terms of the fact that it was like laid out in front of me of what I needed to achieve. It was more of a coding project. So as someone that didn't understand biology very well at the time, that made sense to me. So I simulated biology. That was my PhD. Put out a couple of papers about that, simulating the way iron works in the body.
And then you know about iron, and you jumped into looking into more complex protein stuff, and I don't know, I guess you ironed out proteins and folded them again, and whatever you do with proteins, I don't know, and or put them in a shake or whatever, and then at some point, I mean, currently, as far as I understand, you're working at a school of medicine, right?
Yeah. So my latest move was back to the UK. I went to Los Angeles for the stuff about NF-kappa B, my favorite protein, and now I've moved back to the UK to a medical school in Brighton to think about cancer research.
Sounds like some sort of a secret society at American University or something like that, because there's a Greek letter in it.
It does. The kappa is a nightmare because it's never on the keyboard, and whenever I need to tell people what I do, I can't find the fucking symbol.
Sorry, I didn't want to interrupt you.
Okay. So yeah, I moved back to Brighton because I wanted to work in a medical school. My real passion is trying to get these simulations to help people in the clinic. So I really, that's why I came back to a medical school. I was working in a science lab that was still doing research, but I wanted to take that research and try and use it to make better drugs, to treat people better, and work towards what's called personalized medicine. And so that's why I came to this medical school about a year ago now.
Personalized medicine. What does this entail? I mean,
right.
In
here's my
some
vision.
sort of way, you know, you have a patient, and the patient has some sort of a problem. I mean, I'm coming to you or to some doctor and be like, okay, when I do this and that, I have a pain in my whatever the fuck, and then I get treatment. So in this moment, a treatment is already personalized, because not everybody's treated for having a pain in wherever when doing something. What you are talking about is something else, right?
Right. So here's my vision that I want to work towards. That you go to the doctor right now and you explain what's wrong with you, and they maybe take some data from you, like your temperature or how long you've been sick for, or maybe they take your blood and measure some parameters from your blood. So that's what happens right now, and then they give you some treatment. What I want to do is use these simulations that will take that data. So they might take your temperature, they might take the readouts from your blood, and then put them in a simulation. And now that simulation represents you. And in that simulation, we can say, okay, let's try this drug. Let's try ibuprofen. Let's try avocados. Let's try whatever. Let's try all these different drugs in virtual Simon, and then see what might happen in all these simulations. And then give the actual drug that works the best to that person. That's personalized medicine.
I see. So for this to work, don't you need quite a lot of patient information? Don't you need like an enormous stockpile of data, like a lake or something like that, to actually find things?
Yeah, you have no idea how much data we need, and we have like a fraction of it right now. This goal will take 10 years at least, but the real, it's not necessarily lots of data, it's the right data. And the real powerful data is when the model makes a prediction. So my model might say, if I treat Simon with an avocado at day 7 and then some ibuprofen at day 14, he will get better by day 20. That's my prediction. And then if we try it, now we trust the model. So it's not just lots and lots of data. It's the right data that tests the prediction models.
So how do you get data then? I mean, if I imagine that I would want to create a model of something, right? I mean, I need to have some sort of input, and also I need to have some sort of observations that I can actually use to make some sort of an assumption of what this data actually means, so that I can actually start searching. So how does this work? Are you like buying everybody's Fitbit data, or how does? I mean, I have no clue.
So 90% of it is really uncool. 90% of it is me reading
of course, everything
other
is
people's
uncool
work. There's so much science been done, and so much of it is not understood. So someone in Amsterdam will have measured how quickly this protein is created. Someone in Sweden will have measured how long the protein stays around in the cell. Someone in Australia might have measured how long the immune reaction takes in a certain, how quickly the immune system dies down after infection. So there's all these studies that have gone on in lots of different systems over decades. And so there's plenty of data for me to start modeling with. And once I've matched all of that, if it's consistent and it works, I can prediction, we can test it. There's plenty of data. It's not cool like Fitbit data. It's like a study done in the 80s with some like radioactive protein that they measured or something,
So it's more like this kind of data that X, for example, put into her bachelor thesis, I think. Oh, it was the master. No. Your bachelor thesis. That was the one that actually read like a phone book, because it consisted of lots of other works where people were cited that cited other people that cited things about James Joyce. And then you have, like, I don't know, catalogs of findings about something, and you collect it and you compare, and these sort of things.
Yeah, and when you bring all this data together, it's amazing how many times it's inconsistent. So 10 people will measure something going up, and 5 people will measure something going down. And what do I include in my model? It's difficult. So it's really like drilling down into the data to try and figure out which is right.
Yeah. Of course. I mean, my personal perspective that I ever had on big data sets was, of course, from a perspective of reinforcement learning, of these sort of things, artificial neural networks, and these things that I did back then at university, these gave us quite amazing ways of classification, of putting things in boxes that you wouldn't have imagined that they are there. These sort of things. When I get you right, to the thing that you are doing at the moment, there's actually really a lot of manual labor involved. So you need to look at these studies. You need to understand them. You need to put them. You need to compare them in some sort of way to other studies. You need to figure out which of the models is more sound. And I guess sometimes this is quite, I don't know, experience that you gathered. Or maybe
there's lots of people doing machine learning as well, and that's sort of data driven, whereas what I'm trying to do is knowledge driven. So I'm trying to take what everyone knows and everyone has found out and bring that into a model rather than just being driven by the data. Oh, do you want a cool machine learning story? So
sure.
People so machine learning being hugely used in science, often with images, right? So you go and get your breast scan to look for breast cancer, or your brain scan to look for brain cancer. And you show the scans to an expert, and the expert says you do or do not have cancer. So we try and do this with machine learning now, and machine learning is very good at it, but it can actually spot problems better than people potentially. But it's not always been the case. And in one of the cases, they were trying to predict, get the machine to figure out how long someone was going to live given the size of the tumor that they saw. And what actually happened was that it was really good, but it was just spotting rulers in the images, because any tumor with a ruler next to it was a big tumor, because when you're in the clinic and you get a big tumor cut out, they stick it next to a ruler. So the finding was, if you've got a ruler, you're going to die.
Yeah, this is great. Yeah, as said, machine learning is really, really good at finding boxes that you didn't think about. Like,
yeah.
With or without ruler, that tumor, it was like that big, right? What do you say?
This thing with machine learning, where it had to recognize pictures of sports equipment, and most of the dumbbells that it found, it saw the dumbbell is not separate from the arm holding it.
Yeah, or I mean, one. Yeah, mentioned like a machine learning system that recognized dumbbells and pictures, and recognized them without the arm attached to it, and did really weird things with that. Or I don't know. When I first wrote an algorithm to recognize faces. And we experimented with actually reversing the algorithm to enhance like noise to actually get faces out again. We figured interesting things, like for example that this thing couldn't see glasses. I mean, all of the faces that it would puke out later on, all these people weren't wearing glasses, even though lots of the training material had glasses. So it's doing interesting things, and sometimes it's really funny when people are trying to use it for something really particular, and are even successful with that, but are so far away from it all understanding what's going on there that, they don't see that they actually just wrote an algorithm that knows when a ruler is in the picture.
Right, exactly. That's these data-driven approaches. You have an input, you have an output, you have the image, and you have how long someone's going to live. But how it made that decision in the middle is magic, is pure wizardry. And it's amazing, and it works, but we don't know how it works.
Yeah,
you can sort of figure it out, but we don't really know how it works.
We are calling the place where this information is stored hidden layers. I mean, isn't that mysterious? That's quite amazing, right?
Right. So in my models, there's nothing hidden. Anything that goes into my simulation is something we know happens in biology. So I say this protein connects to this protein, this cell talks to this cell. Everything is driven by years and years of knowledge. So it's much harder to build a model that works. But when you do, hopefully it's representing the truth, as opposed to some mysterious algorithm in the middle.
And when I think about you doing that and actually reading through all of these papers, evaluating all of these studies, isn't it sometimes infuriating when you see that, I don't know, there is some sort of a study, a single one, that pops up in, I don't know, the public discourse, and people say things about it, and nobody's even looking into whether there are other studies or whether the study is sound or whether the method is actually correct, and so forth and so on, and still this is bringing up stuff in the press.
Yeah, it is infuriating, and it's usually, again, it's not people's fault for being stupid. It's just the way that we report on these things. If I could help people not do that, there's some like real basic things that help. No one study ever changes anything you should do, pretty much, unless this study is some miraculous breakthrough, and even then someone will validate it quickly and then we'll change what we should do. So any one study, if you're changing your behavior based on one study, you're almost a biohacker. You're risky. You're like, you know how there's people that buy computers from the shelves, there's people that build their own gaming computers with water cooling and all this sort of stuff. You're like enthusiast level scientist if you're changing your behavior based on one study. So wait, just wait until there's lots of studies, and then it'll be okay. And then the government, the NHS, or the health ministry will tell you should probably change your behavior. That's when you should change your behavior.
Yeah, and at the moment we're at a point where everybody's changing behavior a lot, because I think because of some sort of evaluation, I'm sitting here because I changed my behavior to do super weird stuff online, because otherwise I would just be drinking. So I'm trying to keep my sanity by doing the alcohol while
still drinking, but with company.
yes, because otherwise I'm sure I would drink even more. I mean, wine sales in Germany are like 30% up.
Wow.
Yeah, it's quite
in my
impressive.
house they're at least 50% up.
Well, my gin use is at least 50% up.
Nice. The other
Cheers, by the way.
skill that you can learn to protect yourself. Oh, my wife just brought me another beer. So the other skill you can learn here to not fall for this crap again is the difference between relative risk and absolute risk. So the Daily Mail will put out a headline that says, eating cheese reduces your risk of a stroke by 10%, and everyone stops eating cheese. But that's the relative risk. So you're now 10% more likely than you were before to have a stroke. But 10% of what? How likely were you to have a stroke before? The answer is 0.001%. So it's moved from 0.001% to 0.0011%. Don't stop eating, don't change your behavior based on relative risk. Do it on absolute risk.
I mean, let's face it, I imagine that there are way much worse ways to die than dying of a stroke, right? So, from a rather biohacker enthusiast, water cooling PC user level, I could be like, okay, I should really eat more cheese, way more cheese, because then it's less likely that I'm going to die from cancer.
I mean, there's something to be said for that, and these studies often get this stuff confused. If you don't die of one thing, you end up dying of another, and so you can see these weird effects where we treat a disease, and now all these people are getting Alzheimer's, and we think, oh no, our treatment's causing Alzheimer's, but actually it's just that they're living long enough to get Alzheimer's, so it's a good thing.
Yeah, I mean, this is the thing that people are talking about quite a lot. I mean, since we have amazing phenomena such as COVID-19, we are talking about whether people died from it or with it, as if this makes much of a difference.
Yeah. You don't need advanced statistics to see like the rate of death overall, and then this huge uptake of total death to know that the COVID's involved. It doesn't matter exactly what the final blow was. The COVID was involved, and they wouldn't have died without it. So yeah, anyone downplaying the statistics has an agenda, I think.
Perhaps, or they simply want to discuss whether maybe eating an avocado together with, I don't know, 2 packs of ibuprofen is going to do something.
Yeah, no, there's no problem thinking about these things. You just got to eventually find something that is true and proven by multiple people and not just said by someone for fun, you know?
Yeah. Or perhaps throw the avocados at a 5G antenna. I mean, there was this case not far away. You know, I live in the Ruhr area, which is like a pretty dense place where there are all sorts of cities. And a couple of years ago, they set up all of these 4G antennas, and there were people in some sort of a pub bar or whatever that wrote like a letter to the company that put the mast on top of the building next door, complaining about how they allegedly have health problems now and things like that, and they actually got an answer from them that said like that the company is concerned too. Especially they don't hope that the health of the visitors of this pub is going to continue to deteriorate when they actually turn on the antenna. This happens.
Us humans are really bad at spotting when things just happen to happen at the same time, as opposed to one thing causing another. So, you know, you get sick and the 4G mast has arrived. They presume that the 4G mast made you sick. And the same thing, the classic example of this is the anti-vaccine autism thing, because autism is diagnosed at the same time as people get their vaccines. That just happens to be when the disease shows itself. So everyone presumes, or a section of society presumes, that the vaccines are causing the autism. They're just happening at the same time. And that's where some of this comes from.
But Simon, I know actually for a fact that eating ice cream causes sunburn. I mean, that's quite obvious, right? I mean,
was it just like rulers cause cancer?
Yes. Yeah, causality is a problem for most of us.
There's also an issue of knowing a potential link and presuming that it's real. And so you'll see these studies that say eating ice cream causes cancer or inflammation or something. And you look and it's like one guy once said that maybe because this happens in cells in mice, that it could happen. And the headline becomes that it does. There's actually a really good Twitter account called Just Says in Mice that will find these studies so the Daily Mail headline will be change your behavior now, you're going to die. And they retweet it with in mice, because so much of this is just, it's in mice, don't change your behavior yet, just wait.
Yeah, this is really quite an important point. Some German video blogger that I watched brought this up in something, I don't know, during the past days, and she was like, if you hear about things happening in science or what they do there, try to pick it apart between what is happening and so what does this mean for me actually, and most of the time it doesn't mean much, and usually when it means anything to you, quite often specialists, the government, all sorts of authorities are already involved and are doing a thing.
Right. Every time there's a study, it doesn't mean anything until it's been tested again and again. Once it's been shown, there'll be someone in the government responsible for assessing it, and it will end up being recommended to you, probably by your doctor. So anything else that you're doing based on these studies, based on headlines, it's biohacking. You're trying stuff, and that's cool. You can experiment. Like any experiment, it could blow up in your face, but as long as you're not hurting anybody else, that's fine. It becomes a little bit different if you're sort of...
Yeah, it's a bit like buying Bitcoin or something like that, right? I mean, that's great, as long as you don't put all of your money in it.
Exactly. It doesn't hurt anybody. Give it a go. That's fine. If you want to try the avocado diet, go for it.
Companies to run badly programmed algorithms that are supposed to find underboobs and nipples in porn pictures that people actually want to see, and these sort of things, and are actually wasting CPU cycles on this sort of garbage.
Right. So here's something I need help inventing. I need a cryptocurrency where the computing power you get a Bitcoin, you get a science coin if the paper gets cited. That the computer generates some data, the data goes into a paper. If that paper gets cited, you get paid out a coin, right? So it's like a way of incentivizing people to donate their computers to science. I need that to happen, but I don't know how to do it.
As far as I know, that there are some people that are at least trying to build a cryptocurrency based on folding at home work results.
Yeah, that's pretty close.
And the other thing that you should try, I saw just on our Facebook chat that I didn't use for 427 years, I think. The last thing on the thing that we talked about was the automatic science generator, which is some sort of a grammar that would automatically produce science papers. And if we would try to blockchain that, right? We could try to make a machine that generates science papers until they are cited, and then they're attached to the blockchain, and then they're worth nothing because it's actually just rubbish, right?
Are they ever worth anything, really? I don't know.
I don't know. I mean, there are claims that they at least have 2 math papers that led someone to be invited to a conference.
Oh, you wouldn't believe the conferences you get invited to once you've got an academic email address. I got invited to one the other day for traffic management, and I thought maybe it meant network traffic because I do something vaguely computer science-y, but no, it meant like traffic cones, managing cars in the road traffic, because they just want you to pay to register to go to the conference. There are these fake conferences, fake journals. You get all the invites all the time.
Do you know that there's a tool that can hide cryptographic messages in emails that look like invitations to scientific conferences?
Wow. No.
That's absolutely great because nobody's going to look for these, because nobody's ever reading emails with invitations to scientific conferences. So actually, when you are a scientist and you're already getting those, this should be your favorite form of cryptography, because nobody's going to find that.
Yeah. I have to open all those emails because every now and again it's important, and it's a career-defining conference that you get invited to speak at. I was meant to be going to Germany in June until coronavirus kicked off and speaking at Hematological Society's European Society for Hematology meeting, and I was very excited, but now it's coronavirus, so I have to read all those bloody emails.
That's shitty. I mean, I could, of course, sometimes send you emails from burner email addresses where in the fake invitations to conferences are hidden messages. I actually wouldn't know what I would send you as a hidden message, but I would put hidden messages there.
You've got to be careful. I'll just turn up at your house and start talking science at you.
Oh, that's fine. I have a guest bed. That's great. We can totally do that. Feel always invited.
Amazing. I will. You'll regret it.
No. It's very unlikely. Extremely unlikely, actually. So, yeah. Is something still happening on the channel, actually? Are there people? No? Yes? All the questions have been answered. Yeah. So what does this mean? Are we... Okay, so Sami is allowed to ask an extra question because we're using his shitty t-shirt today to cover the underboobs of Simon. Of Simon's avatar, actually.
He wants to know if the similarity is intentional. I will send you a picture, Simon, so you can answer.
I can't wait.
Oh, you can.
God damn this. So Sami would like to know whether the similarity is intentional.
I see it for sure. more like I'm aiming for sort of a Tiger King thing. If you've seen Joe Exotic from Tiger King, I'm aiming for the like no roots, blonde hair, mullet thing.
Yeah, but you look way too new wave for a mullet.
Oh, it's we're not a month into isolation yet. You wait.
No, you're not going to cut a mullet. I don't believe that.
Oh, don't tempt me. Don't tempt me.
I won't, because I don't want to see that. I mean, I'm not Mark Haig.
Yeah, you've now put the idea in his head, and he will have a mullet already. It's already happened.
Yeah, actually, he will grow the hair and cut it off for it in these minutes, and then he's going to use some sort of weird ass biohacking tools that he, I don't know, ran a computational simulation on his PC computer with the rainbow colored water cooling system.
And yet somehow he's doing amazing work with beet cancer as well. So he's not all crazy somehow.
Absolutely. That's also the reason why he's the next person that I invited, and that I also already have a little Google document with, where I wrote down, well, mainly Mark wrote down stuff like a professional, and I understood like 30% of what he, I don't know, what I think I'm intended to understand. And I didn't tell him yet, but I thought first, first I go to through our Google document, and then I work more on Mark's Google document, and then this is going to be fine, right?
Right, exactly. And you know, the work the sort of charities that he works for is very important for people like me. And when you just start your own lab trying to do this stuff, getting funding from the government is difficult. And so a lot of us are funded by charities. He's funding this sort of work, and at a very important time for people. He might have some announcements, but I'm not going to take them from him. So tune in next time to hear more from him about the work he's funding.
Okay, I got work that Mark is starting a campaign for real Simon Mullets.
Oh shit.
Yeah, I've done it. I'm actually relatively proud about myself now. I think I did well. I think we all did well here, and well, this already gives us a little bit of a preview of next week, where I'll put these boobs on Mark Haig, that's doing beat cancer, and actually it's quite fascinating, right? Because we have people that we met in clubs where you are drinking the vodka that is distilled from the dead bodies that didn't make it out at the last party, and still they are able to I don't know, run cancer research, and then do even, I don't know, support charities to support this cancer research, and this is all running in one circle, and in a lot of cases stuff like this remains completely invisible, which is crazy, I think.
It's so cool that you're doing this and hearing from people that do this sort of stuff. I remember when I was, I moved to Los Angeles to work at UCLA, and people would ask me what I did. I would tell them, and they just had no interest, because, they're trying to get their script across. They're trying to get their show booked. I'm of no use to them. So the conversation was over. And sometimes partying can be a bit like that. Where do you stand in the scene? What do you, which band are you in, whatever. The fact that you're listening to people with interesting jobs is really cool, and I'm really excited to hear from the other ones too.
Yeah, I'm actually quite excited about that too, and I mean, the fields are just so different. I mean, this week we talk about science and related things. Next week about charity. Well, actually in combination with science to some extent, but we still have quite a massive personality from technology on our list. Elena Kovakina. She's working as a technologist at Google, and
Wow.
is doing security stuff at a Team Android, or was. I'm actually not quite sure in which part of the company she's now, but we will figure out in, I think, like 2 weeks or something like that.
I don't envy all the research you have to do.
And it's amazing because I'm quite often amazed about over how many absolutely exciting people I stumble over, while other people are telling me that there is nothing interesting that you can learn in a club. Which is obviously bullshit, because what I know is that everybody at some point needs some sort of space, some sort of zone, where you can actually meet and then meet with people on an eye level, and actually leave all of the all of the traditions that bind you in some sort of way behind, and do something else, and then be something else. And so I think these club environments, these places where people can run into just because of they want to drink and dance, are really vital for a lot of things. And I think we should treat and respect them as such, because this is not just a place for mindless shit. It's the mindless shit that keeps us going, and that gives us the ability to actually drive amazing things forward. And this happened to me a lot, yeah. And well, in the slightly further future, we are going to have literature with Ollie Langmead, the only person that I ever heard about that wrote a science fiction novel in pentameter. And I also asked my friend Irina from Moscow. She's a stunt person. So it is quite incredible into what kind of people you bump into. And this was over the years quite an experience that was humbling to me, because wherever I would appear on some sort of stage, it would inform me about the fact that the interesting shit isn't actually happening on top of that stage. And this was the thing that I found to be always important. And I'm really happy that we can try out whether we can use this thing here as a way to actually reflect this in a slightly calmer way. That is like, let's say 45% less intoxicated and slightly less loud, but gives actually people an idea about what's going on here. And the stuff that's going on is amazing.
And having a shared creative love of this music is a bit of a bridge, right? Even whatever you're into, if you're a stunt man, if you're a stunt woman, if you're doing working for Google, the fact that we share this weird creative outlet that is Straftans and all the weird clubs we go to means there's already a bridge there that I want to know how you ended up in this club and why and what's going on with you. So it already makes it interesting by default. And I'm glad you're elevating the people who don't normally get elevated. It's really cool.
Well, then let's continue to elevate each other. And I think I will use this to conclude this thing. Not just because I think it's a good point of conclusion, but also I really need to pee. Can we actually expect, I don't know, something from science that is going to, I don't know, eliminate this need at some point? Like, I don't know, in integrated Dune Fremen suits or something like that?
I don't know how to make money from it, so probably not. Maybe they'll stop animals peeing so the farms can be cleaner, and then eventually we'll get it. But it won't be for you first. I'm sorry.
Yeah, but with that, you were already, I don't know, like one step ahead of me. 2 steps, at least.
I'll try it. I want it. It'd be good.
Cool. In that case, I will pee now. Simon, thank you so much for coming over and to talk about that.
Thank you for talking to me. It's been fun.
Yeah, was great to have you here. Was great to have you embodied in this amazing technological avatar that we built for you.
I think I look great.
You looked amazing today, and people, thank you for coming. I'd love to see you again or meet you again in some sort of way, but we are not going to do that anytime soon. So because of that, Saturday evening, 8 o'clock, I will start drinking in this room again and do Isolation Rave together with X, and well, next week on Wednesday, we are going to do this again. The global uprising of the uncool, and we'll continue to be goddamn fucking uncool together. So, thanks a lot, and bye. We are out.